element has electronic configuration 1s2, 2s2, 2p6 located in which group? So let's focus on the last two sublevel. You have 2s2 and 2p6, so you need to add these exponents or number of electrons in each sublevel. So 2 plus 6 is going to be 8. We can say it's 8a because the electronic configuration ends with p or 2p, so it must be in group 8a or group 18. So match the letter D. Well, let's figure out the electronic configuration. I'm going to give you a fast review about electronic configuration. Imagine the atom like a big building, consists of floors, like a first floor or first level, a second level, third level, and fourth level. But this is the nucleus. Inside the nucleus you have a protons with positive charge and the neutrons with zero charge or neutral charge. The first level or the first floor occupied by 2 electrons, so this is the maximum of electrons that can be occupied in the first level. The second level occupied by 8 electrons. The third level occupied by 18 electrons. The fourth level is occupied by 32 electrons, and so on. You have the fifth and sixth also occupied by 32 electrons. This is called a principal energy level. It's right here, principal energy levels. Let's keep in mind. And in each level we have a sublevel. So for example, on the first floor we have the one room. I'm going to name it 1S. 1 because of the first level, and S, this is the name of the room. And the second level we have 2 rooms, the 2S and 2P. And the third level we have 3 rooms or 3 sublevels, 3S and 3P and 3D. In the fourth level we have 4 sublevel or 4 rooms. I'm going to name it 4S, 4B because you are on the fourth level, and 4P and 4D and 4F. Keep in mind the S room occupied by only 2 electrons, and the P room occupied by 6 electrons. This is the maximum of electron that can be occupied in each room or each sublevel. And the D sublevel occupied by 10 electrons, and the F sublevel occupied by 14 electrons. So the first level occupied by 2, so here we have 2 in S, the S occupied by 2, and the P, the maximum is 6, so 2 plus 6 is going to be 8. So in the second level, the maximum number of electrons is 8, but 2 in S and 6 electrons in P. Go by the third levels, the S occupied by 2, P occupied by 6, and also here D occupied by 10. So 10 plus 6 plus 2 is going to be 18. Also in the fourth level, you have 2, 6, and then D occupied by 10, and F occupied by 14. If you add it all, it's going to give you 32. For example, you have, for example, the sodium element. The sodium had 11 electrons orbit around the nucleus with atomic number is 11. So I'm going to distribute the 11 electrons around the nucleus to the first level occupied by 2, and the second occupied by 8. I'm distributing 11 electrons. So I put 2 here and then 8. This is the maximum each level. So what's left from 11? So this is 1. So the last orbit occupied by 1 electron, and this is called the valence electron. What about the sublevel? How can I write the sublevel? As you know, the first level M, we have 1 sublevel, 1S, and the second level in 2 we have 2 sublevel, whereas 2S and 2P. And the third level we have 3 sublevel, which are 3S, 3P, and 3D. What about the fourth level? We have 4S, 4P, and 4D, and 4F. Also on the fifth level, it's right here, the fifth also, the 5S, 5P, and 5D, and then 5F. So let's follow the direction of the arrow. You have to fill the sublevel 1S first, and then 2S, then 2P, 3S, then 3P, 4S, then 3D, 4P, and 5S, then 4D and 5P, then 4P, 5D, and then 5F. So follow the direction of the arrow. So let's fill the sublevel according to the number of electrons here. For the sodium, we have 11 electrons. So I'm going to start with the first one is 1s. So I'm going to fill 1s first. So the 1s, the s, the maximum is 2, so it's equal by 2. And what after 1s? Then follow the direction of the arrow. We have 2s, then 2s also equal by 2. And what after 2s? We have 2p. The 2p, the p equal by 6. This is the maximum. So what's left? I have 11 electrons. I put 2 in the first, 2 in the second, and 6. So what's left here? 3s. So 3s, what's left? 1. So this is called the electronic configuration, or the electron distribution according to the sublevel. So focusing here on the first, 1s in the first level, 2s and 2p in the second level, but 3s, 1 in the third level. Look at the coefficient 3. The 3 represents the period. So that means the sodium located in period 3 or row 3, and the exponent here, or the number of electrons, 1. So that means the sodium located in group 1. So if you'd like to detect the location of the sodium in the periodic table, you have to know the atomic number is 11. So from the electronic configuration, we can figure out the location of the sodium atom according to the last sublevel, 3s1. So 3, the coefficient represents the period, located in row 3 or period 3, and the exponent, or the number of electrons, 1, represent the group 1. So group 1, period 3.